Okay, so in this section here of section 8, linear programming, I have a couple things up here for us to fill in if you haven't yet. So linear programming is a method for finding a solution for a system of linear constraints and that you have a linear objective function. So you have a goal in mind. So we have focused on practice graphing linear, we have practiced graphing feasible regions. In this last class period and today we're going to focus on now I have an objective or a goal of something to accomplish from the feasible region itself. Okay? And so in this word problem, we are going to practice writing the inequalities. We're going to find all of the important pieces of information, define our variables, and then create a graph and solve. So the farmer is planting wheat and rye. He has to plant more than 6 acres to be successful. He only has $1,200 to spend on seed. Each acre of wheat costs $150 to plant, and the rye costs $100 to plant. And the farmer has to plant at least 8 hours with his new equipment. It takes 1 hour to plant an acre of wheat, 2 hours to plant an acre of rye. And then we have our profits there at the end. That's the profit is going to be our objective expression, okay, that we're working on. So first of all, let's write out all of our inequalities. All right. All right, so the farmer has 10 acres to plant wheat and rye. We have to define our variables first. Do we want to put, which variable do we want on the x-axis? Wheat. Okay. Sounds good. So x would be the number of wheat acres, and y would be our number of rye. And then we have some different inequalities to write here. So we have a money inequality. Okay, how much money I have to spend on seed. $150x plus 100y needs to be less than or equal to $1,200, right? Then we could look at the time that he has to spend planting. So he needs to plant for at least 8 hours with the new equipment. So we're going to plant 1 hour per each acre of wheat and 2 hours for each acre of rye. And I need to plant at least 8 hours. Kind of like if I needed to be at least 18 to vote, I need to be 18 or older. Okay, so I'm going to have a greater than sign here. And then he needs to plant more than 6 acres. So it's kind of like a requirement that he has. So the number of acres of wheat plus the number of acres of rye needs to be greater than 6. Oh, very first sentence. I have 10 acres that I could plant, right? I own 10 acres to plant.
Yeah.
So I also have a requirement that x plus y needs to be less than or equal to 10. So 2 requirement inequalities there. So on the first 2 inequalities, for time and money, we need to be finding intercepts. Okay? So go ahead, please, and find your intercepts for those first 2 inequalities. So if I plug in 0 for x, I would take 1200 divided by 100, plug in 0 for 100, I'm going to take 1200 divided by 150. Jaden, have you found those yet?
Well, one of dividing.
We're in section 8 of our notes packet. Just getting started. So if we looked at these inequality or our intercepts I have up here in green. Okay? So we had the 150x, 100y, 1200. Our x-intercept was 8 and 12. Our y-intercept was 12. For the 8 hours to plant, my intercepts were 8 and 4. For our time or for the requirement of acres, if I plug in 0, I don't have anything to divide by. So my intercepts were 6 and 6 and 10 and 10. So before you get too crazy labeling your graph and getting started, you should always check your intercepts and see how much space you have available to you. You don't want to have a super small feasible region or scale by 2s if you can scale by 1s, because then you can't really see as good as your intersection points. Okay? Definitely don't want to scale by 2s. And actually, if you scaled by halves and spread it out like every other tick mark, you would have enough space with us putting wheat on the x-axis. We could give ourselves a pretty big feasible region. Okay? So many of you have already scaled by 1s, and that's fine, and we can tackle it that way.
How do we do the like the 6, 6, and
So it's a dot on 6 and a dot on 6. Draw the line. Dot on 10.
oh, okay.
All right, so as you're scaling here and plotting your points, we will
For this, the cost one? Yeah, that's right. Switch it up.
So go ahead again. We're plotting all of our intercepts. Go ahead and take a minute here if you haven't yet. Get these intercepts plotted and think about what your shading would look like.
So it would be what? 0. So if I go. Yeah, I'm not shading all the way. I stopped. One second, I'm trying to find the feasible
All right, guys and gals. So on the board here, listen carefully. On the board here, I only shaded where the four colors overlapped. Okay, so we had 4 inequalities here. My red line from 8 to 12 is my time, and it's everything down. Okay, so if you're using colors, we're going to go from 8, 12, everything down. And then on my time, or my acres here for, or 8 hours, we're going from 8.4. That was greater than, so it's above. My 10.10 line was below, and my 6.6 line was above. So it has to be in between those 4 lines. I had 2 equations that inequalities were greater than, and I had 2 inequalities that were less than. So I'm going to give you about another 2, probably another minute or 2 to go ahead and double check your feasible region and ask questions over where you should be shading. or the dash line, and then the other, the 4-8 line. All right, so now that we have our feasible region done, we can go and look at the objective. Our objective on this problem okay, our objective on this problem is to have as much profit as possible. And our profit on our land, or for the wheat and the rye, is $500 per acre and $300 per acre. And so with that profit line, we want to find which combination of wheat and rye should I plant to make the most money. So we have ordered pairs that we want to check. So at this point you can say, okay, what if I wanted $1,000? You could test maybe a $1,000 profit line. You could test a $2,000 profit line and see what the angle of the profit line is, and that can show you then where to look for your max profit. If you don't want to do that though, which I prefer not to, I already know that the solution comes from a corner. We can look at your graph and start telling me what ordered pairs we should be testing. So down here in this corner would be 8, 0. That's where those two lines intersect. So 8, 0 should be a corner that we test. Okay? Over 4, up 6 should be a corner that we test for profit. Over 4, up 2. Now technically, over 4, up 2, that's a dashed line. So I should be over 4, up maybe like 3. Because I can't make that combination. Because I need more than 6 acres. It should be over 4, up 3 technically. And then over 0, up 6 again, technically is a dashed line, so I should be up at 7. So again, that should technically be 3, and that should be 7. So those are all of the corners of our feasible region. On your paper, I need you to write down those corners, and I need you to start testing them in your profit equation. I need you to calculate the profit for all of those ordered pairs. Calculate the profit for those ordered pairs. So we would take 4 times 500 plus 6 times 300. Take your x and your y and plug them in. So, not the 150, then the profit was the 500 and 300. It's going to be 4 times 500 plus 6 times 300. So check the profit for each of those ordered pairs. We'll wait about another minute or so. Yeah, I would like the profits over here on the side. Okay, so you plug in those in. 500 times 4, 300 times this, the wheat, and the rye. So added together. This is X, Y. So I have a profit equation on the paper. Or 500x plus 300y equals profit. We won't plot these values because they're not necessarily you could. These ordered pairs are already on the graph. We just want to figure out what their profits are. Okay. If I asked you to plot the $2,000 profit line, then you could plot that. But these are just going to be the profits that you're finding. Okay, so let's update these numbers for me because 2600 and 1800 aren't going to be correct. So Jackson, can you tell me what 07 gets us?
2,100.
Okay. Let my computer catch up here. Okay, so the ordered pair 07 is going to get me 2,100. Molly, what did 4-3 get me? Okay. Riley, do you agree that 010 is $3,000?
Yeah.
Okay. Isaac, what's 80 going to get us? So 500 times 8. Okay. And Haley, can you tell me what 4-6 was going to get us? What did you say? 3,800. Okay. I agree with that. So on this feasible region problem then, the max profit is coming from 80, and that's this bottom corner down here. So our solution, he will have this farmer will have the most profit if he plants 8 acres of wheat. And 0 acres of rye. So 8 acres of wheat and 0 acres of rye would be our solution.